Back. So now we are going to improve our first attempt at defining square root function with a second attempt, square root b. Okay. So remember, in the first case we got into an infinite loop. So let's avoid that by saying, okay, keep improving your guess for 100 times, and that's it. All right. So here is a new definition: square root b of a number. All right. Everything else is same. I'm not using a while loop though. I'm just using a for loop. I'm going to try improving my guess for 100 times. That's it. Okay. Now return it. Okay. Save. Run. Okay. So let's see. Now this function is called square root b of 25. Okay, square root b of 16 is good. Square root b of 17 works like it did, right? Now you want to do square root b of 18. Look, in the previous case, it was 18 that crashed, it went on an infinite loop. Let's try this. It stopped after 100 attempts. So this is a good one. So what could, now you think as a programmer, what could this be, what could be a problem with this one? Well, the problem is you might actually find an exact root earlier. Why? Then you're repeatedly going through this so-called improvement which doesn't do anything more for you. Say suppose you are working at 25. Suppose at the fifth, at some point you got the number 5. 5, 25 over 5 is another 5. 5 plus 5, 10 over 2 is a 5. So your guess started with 5, ended at the new guess is again a 5. So once you got your answer, you are still continuing one up to 100. So you're inefficient. So your program is continuing for the rest of the iterations unnecessarily. So we can improve it. We allow a certain error, allowable error. This is a variable we introduce, allowable error. Let's allow an error of this. As long as guess minus number divided by guess, right, is bigger than the allowable error, you improve it. Otherwise, don't. But you see, I want absolute value because my guess might be smaller than this, might be greater than this. So I want absolute value of the difference. Okay, so let's try what happens. Okay, so this is an even better improvement. Let me start again. This is my definition of square root c of a number. Oh, square root c looks like a parenthesis of a number. Of a number with an allowable error. So default allowable error is 0.1. How many zeros are these? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1. So this is the default allowable error. Okay, if the user gives some other default, that's fine too. Give some other allowable error, that's okay too. While absolute value of guess minus number over guess is greater than allowable error, correct? Improve your guess. Okay, and don't forget to return. Mind you, return is not in the while loop. It has to be aligned with the while loop. And let's run this. Okay, so square root C of 25 is good. Aha, it did something though, right? It kept improving. So it should not have given 5 point blah blah blah. Why? It kept improving until you crossed a certain allowable error. What that means is, look, it crossed, this is within allowable error. That's why that's your answer. I hope it's clear, yeah? So in the earlier cases, you actually found the answer within 100 iterations. The one before that, you had infinitely many iterations, it found an error. It found the actual answer. But this one, you had an allowable error. The moment you satisfied that allowable error, it gave you an approximation. So you found an approximation well within the allowable error and the program stopped. That's why you have an approximate value. Square root C of 16. Let's see what happens here. See again, you found an approximation well within allowable error, so we got out of the while loop and you found an approximate value. So it did not keep improving until you got the correct answer. Okay, so why is this a problem? Well, because you can get into an infinite loop if the caller passed 0 as an allowable error. See, allowable error default is this number, but what if I say square root C and the allowable error is square root C of 16, allowable error is 0. I don't want any error. So it kept working even after this until it got the exact value. But look at that. I say 17 and I don't want any error. It worked. Square root C. 18, I don't want any error. And there I have an infinite loop, which is a problem. Okay, so we need to improve that one also, which brings us to square root D. Okay, this one I will ask you to type in a file like this. Make sure you type all these things because typing is the only way for you to get comfortable. So even though you're watching me type here, it's better you type by yourself so you get a good feel for it. Okay, type in this code. Here you have a distinction between present guess and a previous guess. All right. You start with a guess, which is minimum of 1 and your number. As long as previous guess is smaller than your current guess, you're improving. Okay. In other words, starting from 0, which is your previous guess, you're improving until you cross your guess. Okay. So try this one and play this one. Type it here. Make sure you type all of these yourselves. Okay. This completes lecture 6, and I would honestly like you to type every single code that I have typed myself. Okay. Okay then, until then.